You can multiply two numbers and that you write as a times b, or you can write the shorthand just a, b, meaning the same thing. So to multiply means repeated addition. That's normally how you define multiplication. So you can define it as you add b to itself a times. And then some results follow. For example, if I have 3 times 4, what do I get according to this definition? Yeah, you should add 4 to itself 3 times. So this becomes equal to 12. And then I could also multiply a negative number. For example, if I take 3 times minus 2. That means minus 2 should add to itself 3 times. And that's just minus 6. So you see that 3 times minus 2 is the same thing as 3 times 2, 6, but with the minus sign. So here we have an example of plus times minus equal minus. However, according to this definition, we can't still work out yet what this will mean. We can't use this definition to work this out because we can't add 2 to itself minus 3 times. Nor can we figure it out using the definition what this is. So according to definition, this is not defined. But there are other ways to define negative multiplication of negative numbers, and we'll come back to that soon. We can also multiply if we have, for example, 0.1 and multiply it with 30. And multiplication, in this case, we can't add 30 to itself a tenth of the time. But if we generalize the definition here now, this definition holds for natural numbers here, but if we generalize it, we can interpret or define this multiplication sign as of, taking of something. So this means a tenth of 30. And what is a tenth of 30? That's 3. And what would this mean? 2.1 times 30. That would mean taking, according to this definition, 30 2 times, and then adding a tenth of 30. So we could think of this as 2 times 30 plus a tenth of 30. So this is 60. This is 3. So this is 63. So this means taking 2 and a tenth of 30. Then we get 63. So we take 2 whole of 30 and then a tenth of 30. And then we have several multiplicational rules. For example, commutativity. It says that it doesn't matter if you have a times b or b times a. The result is the same. So for example, 2 times 3 is 6. But 3 times 2 is also 6. And how do I know this, by the way? I can use the definition here of repeated addition. 2 times 3, that is 3 added to itself 2 times. And 3 times 2 is 2 added to itself 3 times. And this holds generally. So that's one multiplicational rule we can always use. It works for all types of numbers. So all these rules we are talking about will hold for all types of numbers, but often we also only motivate them for integers, for simplicity. And all numbers, I mean all real numbers. Another rule we have is a Certity Rule. So if I have 3 numbers and multiply them, it doesn't matter if I multiply these 2 first, or I multiply these 2 first. So parentheses here mean that I should do this first, and in this case I should do this first. So for example, if I take 2 times 3 times 4 and put the parentheses here, then doing this first, that's 6 times 4. that's 24. And the other situation is 2 times, then I should do 3 times 4 first. And 3 times 4 is 12. And 2 times 12 is also 24. So you see that we end up with the same number. It doesn't matter where I put the parentheses. And this holds in general for all numbers. So that's another rule of multiplication. As we already talked about when we talked about addition, we have priority rules. So you can put out parentheses. For example, if you write 2 times 3 plus 4, then you could ask yourself, what should that mean? Should I multiply first or add first? Does it matter? Yes, it matters, because if you multiply first 2 and 3, you get 6, and then adding 4, you get 10. But if you instead add first, you get 7, and then multiplying by 2 is 14. So you need to know what this means. Does it mean that this parenthesis should be here, or that it should be here? Yeah, then you have priority rules, conventions, saying that if you have both plus and minus, and also maybe subtraction and division, you should always do multiplication and division first. So this means implicitly that we have parentheses here. But using these priority rules, we don't have to write out the parentheses. So this means, in actuality, this, and not the other one. So in this case, it will be 10, the first alternative. So that's priority rules for parentheses. And parentheses means, in general, that you should do the operations in parentheses before you do things outside the parentheses. Then we have the distributive rule, and that says that if you have multiply a sum, the rule is that you can multiply the terms in the sum one at a time, or both of them. So you can intuitively think of that you multiply in a here and here. So for example, 2 times 3 plus 4. You can multiply first 3 with 2, and then 4 with 2. And we see, why does this work? Yeah, we have a separate video for motivating why this works. But this will hold for all the real numbers. So we can always use this rule here. And also, it doesn't matter if I have a minus sign. I could also write like this. So that means A times B, A times C. So you can also use this rule. It will always hold also. And this can be generalized if you have sums, if you multiply sums. So let's say we multiply 2 sums. Then we should multiply all combination, that with that one, that with that one, that with that one, and that with that one. And doing that, we get A times C, A times D, and then we should have a plus in between. And then B times C, and B times D. So this here is a rule we can use for multiplication of sums. And then you could, let's take an example then. We'll take 2 plus 3, 4 plus 5. Then I have 2 times 4, 2 times 5, 3 times 4, 3 times 5. And then we just have to do the multiplications. 8, 10, 12, 15. And adding up 12, 8, that's 20, 30, 45. Okay, so that's the rule for multiplication of sums. Actually, this one don't have to use this as a separate rule, because these follow from commutativity and distributivity. So you have this rule, and that multiplication you can change order. It follows logically that this must hold. But it is good to have it written down explicitly. One could also multiply differences and sums. So for example, if I have, let's take some little bit larger number, 3 minus 2 and 5 minus 1. Then I can do it the same way as I had with sums. I just multiply all combinations. So the rule is the same whether if I have plus or minus signs here. I can also have plus and minus signs in front of these, that is negative numbers. In this case I have to multiply 3 and 5. And then I have to multiply 3 and 1. But since I have a minus sign, I have to put the minus sign here. And then 2 times 5, but then I have a minus. And then 2 times 1, but I have 2 minuses, and 2 minuses make a plus. So this is 15, 3, 10, and 2. So 15 minus 13 plus 2, so that's 4. Of course, in this case, it would have much simpler to do the parentheses first. This is 1, and this is 4, so 1 times 4 is 4. But this just to illustrate how it works. Here we see that I have used implicitly the rule that multiplication of minus signs. Minus times plus is minus. Plus times minus is minus. And minus times minus is plus. So we can write this as in this way. If I have one minus sign, and it doesn't matter on which factory it is, this will end up as a negative. I will have a minus sign here. And if you have two minuses, they will cancel, and we will have AB. Or yes, AB. So this is the rule that says that if you multiply plus and plus, you get plus. Plus and minus, you get minus. Minus and plus, minus. And minus, plus. So two different kinds of minus. If you have minus on one and not on the other, then you get minus. But if you have the same on both, plus on both or minus on both, then you get plus. And I will put a link down here now for an article you can read if you want to know more about why is plus times minus, minus, and so on, because it's a little bit more complicated. But this is the rules for stating that that's the fact. And using that makes all other rules just work in the normal fashion. So I'll put the link to the article about why minus times minus is plus and so on. I put it down in the description.